Alright guys, welcome back to your 60th C++ tutorial, and in this tutorial I want to talk to you guys about class templates. So before we learn about function templates, but in this tutorial I want to tell you guys, aside from just functions being able to use templates, entire classes can use templates as well. And again, by template all I mean is a generic data type. So let's go ahead and build it right now. So, just like before, the way you make a template definition doesn't change. You go ahead and write template, and then inside your angle brackets, you write class, and I might as well, start good programming practice and use what people typically use, and that's just one capital letter instead of, a word. You can use a word, I like using a word, but since I'm teaching you guys, might as well get into a good habit. So now, after this, now we basically made a generic data type. We can begin making our class. So go ahead and make a class. I'm going to name mine Bucky. And let's say that, well, let me add my semicolon before I forget. Bucky is going to have two variables. Now we don't know what those variables are yet, whether they're ints, doubles, so I'm just going to name them T, my generic data type. One's going to be named first, and one's going to be named second. So now let's throw a couple functions inside Bucky. So they're both going to be public. Might as well go ahead and make our constructor Bucky, and in our constructor let's just go ahead and for two numbers set first and second equal to whatever numbers we pass in. So TA and TB. Basically we're passing it in two numbers which we don't know what type of numbers they are yet. So now let's just go ahead and set first equal to A and second equal to B. So now these two numbers in Bucky are going to have a value. So that's what's going to happen whenever we first build a Bucky object. So now after this, we can go ahead and just add another method like T bigger, and all this is going to do is it's going to find out which number is bigger. We'll actually keep this constructor definition right in here, but we'll take this bigger function and we'll build it outside, because there's a couple of different rules I want to teach you guys. Whenever you build function template, what did I say? Function template? What the heck is that? Whenever you build a function member outside the declaration of the class template. So let's go ahead and do that right now. Let me make sure I have all my semicolons in the right place. That looks good, that looks good. One down there. Looks good so far. I guess we'll find out later on when I run it. But okay. Now the first thing I want to note is that even though we made a generic type of data right here, whenever you have a function member outside the declaration of the class, and remember, we said we're going to be building a function called bigger that belonged to the class Bucky, but we're going to be doing it outside the class, we always need to have that function definition again. So go ahead and copy this and paste it. I don't know why they made it where you needed it again, but they did. So before every single function, you need to have that. Now here is how you start out building your function members outside the declaration of the class template. You first write your return type, and our return type is of course T, just our generic return type, and then just like before you write what class you're going to be working with. So I'm going to be working with Bucky, and I'm going to be building a function called bigger. But we just can't go ahead and type, the function body right here. We need to do something first. Right after your class name, you need to add angle brackets and add your T right here too. And this is because we need to tell C++ that the function's template parameter is the same one that we're going to be using for the class. So in order to do that, we need to specify that T inside angle brackets right after the class name. If you're saying that's kind of weird, well, I agree with you. It is kind of weird and it's kind of stupid too, but if you think this is stupid and complicated, you're going to have to take it up with the people who made C++. I just teach it. For the record, I don't think it should be made this way, but after the class name, you need to include that function template parameter. Again, I think it's a stupid way of doing it, but hey, I didn't make C++, I just teach it. So now we can go ahead and, well, of course, this function called bigger is just going to take the two numbers, that are in the Bucky class first and second, and it's going to find which one is bigger. So it's basically going to be the opposite of what we did last time. So just go ahead and return, and we'll compare. If first is bigger than second, then return first, else return second. So this looks good to go right now. Well, I think that's all we have to do for our class. So basically, we have a class called Bucky. Now, Bucky has two variables in it, a first and a second variable. Now, whenever we make a Bucky object, that's when we give the first and second variable their values. So first is going to be like 10 and second is going to be like 20. And now we have another function just to find out which number is bigger. So whenever we call the bigger function, it's going to take the first number and the second number, which would be like 10 and 20. If 10 is bigger, it's going to return 10. If 20 is bigger, it's going to return 20. So now let's go ahead and make our Bucky object and run this, and let me show you guys how it works. So if you think you guys know how to do this, you don't, because there's one other little weird thing that you have to do. You go ahead and make your Bucky object just as you think you would, making Bucky object, and since this is a constructor that takes two parameters, first and second, we need to give it its two numbers like 69 and 105. And now after this, we can go ahead and see out bo.bigger, and remember, this bigger doesn't take those two numbers as parameters. Since this class already has two variables in it, it's just going to go ahead and grab those variables. So as you can see in this bigger function, we don't need to pass it in those two numbers, it already has it. So let's go ahead and build and run this, and you say, alright, what the heck is this? Why are we getting an error message? That's because whenever, well, let's read the error message. I'll show you guys what it says. Missing template arguments before BO. Whenever we're working with the class template, we need to explicitly tell it what type of data we want to substitute for t. And we're going to be working with integers because 69 and 105 are integers. So between your class name and your object, you need to pass in I and t in angle brackets. So like I said before you go ahead and start making these objects, if you think you know what you're doing, you don't. This is what people typically forget. So in the last couple tutorials, we could have done this and it was optional. I decided to exclude it. Well, in this tutorial, we absolutely need to have it. And whenever we do this, we're basically saying, alright, this is what we're going to be substituting for t. So if this was double, and we made our class object, anywhere this class saw a t, it would plug in double right here. These two numbers are doubles. When our constructor is made, we're going to be passing in two doubles. Whenever you run the function, it's going to be a double instead of a t. Well, since we're going to be working with integers, we're basically telling our class, anywhere you see a t, substitute integer for it. So that way we can work with, different types of objects, and maybe we'll make one class an integer and one class a double. And well, let me go ahead and first run this and show you guys that it indeed works. 105 is indeed the bigger number. And if you don't believe me, I'll just change this to 258 and run it again and show you guys that our program is working correctly. So basically, there are a couple weird rules. The first rule I want to tell you guys is every single function you build, you need to precede it with this function template. It's kind of weird, but it's what you need to do. Also, you need to have the blank generic data type after your class name, and this pretty much tells your function that we are indeed working with the class's template parameter, which is this one. And also, the last thing you guys got to watch out for is whenever you make your objects, you need to explicitly tell your object what type of data to substitute for t. And you do that between your class and your object declaration right here. So there are a couple of weird rules. Again, I want to say this. If you guys are stuck on templates and this is just way too confusing for you guys, all the substitution, forget about them. You don't need to build it. It's just if you want to build a program that takes less code and makes it a little bit easier, then you have the option of doing this, but it isn't a requirement. So if you don't completely understand it. Don't worry about it. You can move on, and you're not going to be lost on C++. So anyways, thank you guys for watching. Don't forget to subscribe. Don't forget to check out my website, and I will see you guys later.